I want you to set up your notes something like this. I don't want you to copy down all the words in the example. I'd put down this drawing right here. And then on this next one, put down this drawing. We're going to focus on that kind of stuff as we're taking our notes. And I think if you remember this rule, that probability of an event happening is the like the total possible things that could happen, total possible, and you're going to divide that total possible into your favorable outcome, what you want to have happen. All right, so let's study that idea over and over and over again with these problems today. All right, let's say you become a wildlife biologist and you're studying frogs, and you see there are three frogs sitting on a log here. There's 5 feet between the first two frogs, and then there's another 10 feet between the second frog and the third frog. And the question is, what's the probability that another frog is going to jump up on the log and land in this region right here? That's really their question, because it says it lands between the first two. And remember what I said with probability problems, it's like a lot of reading and trying to understand what the author's asking. They're setting up a scenario for us. And I know a lot of people say, well, I'm not interested in being a wildlife biologist. When am I going to use this? I want to be such and such. And it's pretty normal for people to not know exactly what they want to do. So I want you to hesitate, in jumping into conclusions like, this is an interesting problem to me. I don't see how I would use this, because it's more of just an exercise for our brain. And then if you go into a certain field that requires you to use logic like this, you'll have the equipment, the tools to do that. And this kind of stuff is on our kind of graduation test, the SBAC, right? So you can do it. That's the other thing. Be thankful that you have a brain that can handle this level of abstraction. So let's see if we first understand the problem. We want to know, what's the chance the frog's going to hop up like here. We don't want to know where it's going to, like hop up over here. And what I was saying was, in our rule for probability, where, like what is our favorable region, and we're going to divide it by where the frog, or where the, what's the total possible places that something could occur. So we want the favorable area divided by the total possible area. And I use the word area when we don't really have an area on this log. I mean, some people would say, yeah, you have to have an area, but it's really a length that they're talking about, right? 5 feet long and then 10 feet long. So what is our favorable in this situation? Well, it's 5 feet. Okay, so my probability that the frog's going to end up where we want him, so probability of frog, I'm going to abbreviate it like that, is equal to the 5 feet divided by the total length, right? The total length is our total possible, so I'm going to divide it by 15. And that comes out to be 1/3. So they might ask us to write it as a fraction. They might ask us to write it as a decimal, rounded to 2 decimal places, so 0.33. Somebody was saying that if you don't put a 0 in front of your decimal, it doesn't count it on McGraw-Hill. Sometimes it might ask us to write it as a percent. So be ready for all 3 of those ways of writing a probability. All right. So let's use that idea even like in a further level of abstraction. Okay. This, by the way, is going to be one of our homework problems today. On example 2 in the textbook, they're saying there's a website that, posts some images, and they update their website every 6 minutes. And the question is, what is the probability that you're going to have to wait for longer than 5 minutes, 5 or more minutes, before the website refreshes the image that it's posting? Okay. So it refreshes every 6 minutes. 6 minutes is going to be our total amount of time. Okay. So that's our total segment length, right? And I know this sounds weird, but our favorable is in this last minute. Like if they post something right here, we want to know, what's the chance that we're going to have to wait for 5 or more minutes. So we'd have to wait. And then we'd have to wait over here. This would be between the 5th and 6th minute, right? So this is really our favorable right over here. This is our favorable, even though it wouldn't be good to wait a long time. But according to the question, we want to know how, what is the probability that we have to wait for at least 5 minutes, right? 5 or more minutes. So this is really what we want to know. We want to end up right here. It's like the frog. We want the frog to jump in right there, right? So what is that length right there? It's 1. Between the distance between 5 and 6 is 1, right? So that length is 1. So my favorable, let me write it out here. Favorable is equal to 1, and my total possible is equal to 6. And so my probability that I have to wait for at least 5 minutes, between 5 and 6 minutes, I should say, wait time, it would be 1 out of 6, because our 1 minute and then out of 6 minutes is how we're kind of thinking about that. It's like a segment, just like the segment length that we had up there. Okay, so it's favorable over total possible. Let's relate that to an area problem. So there's this parachutist aiming to land in a circle on a field that is 120 by 30 yards. Now, you kind of on these problems have to say, he's going to or she's going to land on the field. They are going to land on the field. Okay, you got to take that as an assumption. And where they land on the field is going to be completely at random. They don't have skill to really angle themselves to the circle. So when they ask this kind of question, they're assuming a lot. They're really saying, hey, the parachutist could land anywhere on that rectangle. All right, so that's our total possible. So the rectangle is 120 by 30. Now, if you're like me and you've seen those parachutists jump into stadiums, before a game starts and stuff like that, it's like shocking that they do that. It's amazing. They look like they got a lot of control over where they're going to land. So it's hard to put that knowledge that I have out of my head and say, okay, the parachute is going to land randomly in this field. But that's what we need to do for these kind of problems. Okay. So what is the total area? The total possible is 120 by 30, right? That's our area. So I'm going to go 120 times 30, and 3 times 12 is 36, right? And then I need to add another 0 and another 0. So I think I get 360020. So 3,600 square yards. Okay. So that's the size of this field. Now we need to figure out what the area of the circle is. So the favorable, let me put it above this. Favorable is a circle with radius 10, isn't it? Doesn't it say 10-yard radius? That's super important, because the formula for a circle is pi times the radius squared. And so I get 100 pi square yards, right? Probably should keep the units here. So yards there. And so I get 100 pi square yards. So my probability that the parachutist lands in the circle, if it's completely random where the parachute is going to land, is 100 pi over 3,600. Okay. What is the probability? Okay, he lands in the target. Now, it doesn't tell me where I want to round to. On McGraw-Hill, it's going to ask us to round or keep it exact or do something. So be very careful, when you go to Desmos, that you're rounding correctly. I hope I'm making this clear. I know you can do this stuff. I know it's challenging. Thanks for your hard work.